Okay, folks, so we're moving into the next unit, and our first section is to discuss rates of change, which we've talked a little bit about already, but now that we've learned how to calculate derivatives effectively, and we've built some sort of graphical interpretations of derivatives, now we want to return to the idea of rates of change and address the subject directly. So there's lots of applications of rates of change. Perhaps the easiest ones to access, though, are changes in position or changes in velocity or changes in acceleration, that is, changes in motion. So before we get into that, I want to make sure we understand some of the terminology. So let's first talk about the difference between the words distance versus displacement. And these two words are sometimes used incorrectly, interchangeably, and so we want to be a little more careful with that now. So for distance, I'm not going to give a great definition for it, but let's say that distance is how far an object travels along a given path. Okay. And we will get a better definition of distance later on when we get into Chapter 5 and when you move on to Calc 2. You'll get kind of different interpretations of what we mean by path. But right now we could say the distance an object travels is simply how far it goes along a given path. Let's look at an example of that. So let's say we've got a person that's going to start off walking. Let's go ahead and give them a compass for reference here. We'll say that's north, there's south, there's east, and there's west. So the person starts off, let's say, walking north, and they walk a distance of, say, 6 miles, 6 kilometers, something, we'll say 6 miles north. And then they head west, and they walk a distance west for, say, 4 miles, and then let's say they come down 3 miles. So if I ask you how far did this person walk, you would simply add up the legs, the different legs of this journey, and the distance that this person walked would be 6 plus 4 plus 3, or 13. We went ahead and said we'd go with miles. So the distance this person walked was 13 miles. Okay. Notice that somebody else might walk to the same spot, but maybe they take this as their path. And so this person would have walked 4 and then 3. So the distance this person walked would be 4 plus 3, or a total of 7 miles. Okay. Finally, maybe somebody who's a little cleverer than the first two decides to walk this direction at an angle, and that would be, well, let's see here, that's a right, assuming that's a right triangle, and I meant it to be so. So that would be 4 squared plus 3 squared square rooted, so we get a distance of 5 miles. So the third person traveled a distance of 5 miles. Okay. Well, that incorporates the idea of how far an object travels along a given path, and that's from some sort of starting position. In this case, this was our starting position right here, and this was our stopping position. I guess we could label that stop. Okay. And so we see that distance depends upon the path that you take to get to that location. Okay. As opposed to displacement, which is a question of how far is an object from its starting position. Okay. And to be honest, when I calculated this distance of 5 right here, I was using the Pythagorean theorem to come up with the total displacement. But you saw me kind of shortcut and use what we know about the right triangle. The displacement, though, is path independent. Okay. So what would we say here? We would say that all 3 of these individuals, let's see if I get another color here, all 3 of these individuals have a displacement of 5 miles. And I should include a direction on here. So I'm going to say 5 miles to the north west, approximately. That's not perfect here. I don't actually have their compass heading, but it's to the northwest, we'll say. A displacement of 5 miles to the northwest from the starting position. So that's what we mean when we talk about the difference between distance and displacement.